So what we are going to start with this, we were doing exercise 7.1 and we were left with question number 6. So let's start with question number 6. So what we have is a given 5 flags of different colors. How many different signals can be generated if each flag requires the use of 2 flags, one above the other? So they said that in the question there are 5 different flags. So suppose we have flag 1, flag 2, flag 3, flag 4 and flag 5. We have 5 different flags. And then how many different signals? So what are the signals they are talking about? Signals are nothing but signals can be generated if each signal requires the use of 2 flags. So each signal requires the use of 2 flags, and the 2 flags will be one below the other. So suppose this one is one flag, then the other flag will be in here. Suppose I say F1, so this one will be F2. Clear? So this is how a signal is formed. So signal is formed by one flag below the another. So this, and for a signal we need 2 flags only. So how many signals we can generate by using these 5 flags? So now you see this problem is just like the box problem I told you. Now in here we need to generate the signals by the use of 2 flags. So what I will do is I will just write the box like this. So I will have the box of 2 compartments. So in that 2 compartments, why 2 compartments? Because we have 2 flags, or else you can draw the box like this, one of the other, or else you can draw the box like this. So we have 2 compartments. Now in the first place you can put this box, this compartment can be filled in how many ways? Now in the first time we have 5 flags, so we can select any one of the flags from these 5 flags. So basically we have 5 ways to fill the box number, the compartment number 1. Now the compartment below this compartment can be filled by how many? It can be filled by, suppose I have used F5 in here. Suppose I have used F5 to fill the first compartment. So I cannot use F5 again. So if I use 1, then I cannot use that one for the second compartment. So the number of choices will be 4. So I have here 4. So basically by multiplication principle we can say that the number of signals we can generate is 5 into 4, that is 20. Okay, so let's do this one. So first I will do what? First we will write that the number of ways, or the number of signals generated is equivalent to the number of ways I will just draw a box like this. The boxes can be filled by the 5 flags. Okay, clear? So I will write here the first compartment can be filled in 5 ways. The first compartment can be filled in 5 ways, and the second compartment can be filled in 4 ways, which we have already discussed. So the second compartment can be filled in 4 ways. So therefore the total number of signals will be nothing but equal to the total number of ways, and total number of ways is what? It is 5 into 4, that is 20 signals. So we can generate 20 signals by using those 5 flags, 2 at a time. Now, so this is it. We finished our multiplication principle in here. Now the next topic is permutation. The next topic is very, very important. So it is permutation. Now what is permutation? So first let us start with a definition of permutation. So permutation says what? It is an arrangement in a definite order So it is an arrangement in a definite order of a number of objects taken some or all at a time. Taken some or all at a time. So basically, what is the main thing in here? Here it says what? It is an arrangement. So it is what? It is an arrangement in a definite order of a number of objects taken some or all at a time. So basically, first we have to do what? We have to take some objects with the given objects, then we have to arrange those objects. So what you have? So first, suppose I have given 5 objects. Then out of these 5 objects, my first task will be to select some objects. So let us select. So first I have selected 3 objects. First say that I selected 3 objects, and then my next task will be to arrange those 3 objects. Arrange those 3 objects. So that is what permutation is all about. So permutation is nothing but selection and arrangement. So this is what permutation. Okay, selection and arrangement. First we select, then we arrange those. So let me start with an example. Suppose we have 3 objects A, B, C. Suppose we have 3 objects, and here what I will do is I will do the permutation. And basically I will arrange these 3 objects 2 at a time. So when I say I will arrange these 3 objects 2 at a time, means I will be selecting 2 items and then I will arrange them. Okay. So first of all, let us select AB. So if I select AB, I arrange AB as AB. Then I can arrange AB as B also. Right. So first I selected AB, then I arranged it as AB and BA. So 2 arrangements done with AB. Then I select BC. Again we have selected 2 items. Then we can arrange BC as CB also. Right. And then again we have selected AC, and we can arrange AC as C also. So these are the possible arrangements we can see if I take 2 objects at a time from these 3 given objects. Clear? So here it says what? It is an arrangement in a definite order. These are arrangement in a definite order. Definite order means what? AB and BA are not same. Definite order. The order is important. When you're writing AB, when you place AB in front of B, that is not equal to when B is placed in front of A. So the order is important. Arrangement in a definite order of a number of objects. So of a number of objects A, B, C I am arranging. Taken some. So here I am taking 2 at a time. 2 or all at a time. Now let us do an example where we are taking all the objects at a time. So what do you get? So if I take all the 3 objects at a time, select all the 3 objects and I arrange them. So what do you get? Suppose I have taken ABC at the time, I arrange them as ABC. Then I can arrange them as ACB. Then I can arrange them as BCA. Then I can arrange them as BAC. Then I can arrange them as CAB. Then I can arrange them as CBA. So I think these are the possible ways we can arrange ABC. Taken 3 at a time. Right? So basically how to know this one. Now obviously we will not be writing we will not be selecting each and every elements like this and write it in definite orders and we will count like that. We cannot do like that. So what is the shortcut to this? The shortcut to this is, since we are taking from 3 elements, so basically the definition is what? Permutation of 3 elements, 3 objects taken 2 at a time. This is denoted by 3p2. This thing in here is known as 3p2. Okay, and this thing what we have done is known as 3p3. This is 3p3 and this one is 3p2. Okay, I hope it's clear. Now what we are going to do is, now let's see what is basically 3p2 equal to. So 3p2 is equal to how much? So let's see. So now 3p2 is nothing but, can I write how many elements we can see in here? 1, 2, 3, 4, 5, 6, right? So we have got 3p2 as 6, right? So can I write 6 as 3 into 3 minus 1? That is got 6. It's basically just like this only. We have 2 boxes to fill and we have 3 elements. We have 2 boxes, we have 2 compartments to fill and we have 3 elements. So how many ways we can fill this one? There are 3 ways we can fill this one. And how many ways we can fill this one? There are 2 ways. So 3 into 2, that is 6. So that's how we got 6. Okay, clear? Understood? So 3p2 is equal to 6. Now 6, I can write it as what? 3 into 3 minus 1. I can write. So this become, why am I writing this one? I will tell you what is the reason of writing this one. So 3 into 3 minus 1, that gives us 3 into 2. So that gives us 6. Right? Now when we are taking 3 objects, from 3 objects, 3 at a time. Now what is the value of 3p3? Now the value of this thing, here what we see, now we are taking from 3 objects, we are taking 3 at a time. So it means what? We have a box of 3 compartments. We have a box of 3 compartments. So the first compartment can be filled in 3 ways. The second compartment can be filled in 2 ways. And the third compartment can be filled in 1 way. Right? So this is also what? 3 into 2 into 1. That is also 6. And here this one can be written as 3p3. Why? Because I am selecting from 3 objects. And how many objects I have selected? I have selected 3 objects only. So here you see arrangement is 3 objects. Here the arrangement of 2 objects. So here 3p3 can be written as 6 and that can be written as 3 into, look at here, 3 into 3 minus 1 into 3 minus 2. Here we are writing, we had 2 compartments. So we have writing 3 into 3 minus 1, that is 3 into 2. And this one we are writing 3 into 3 minus 1 into 3 minus 2. It's just like if I fill one box, then the other box, how many numbers we can fill the other box? 3 minus 1. Then the other box, how many numbers we can fill? 3 minus 2. Because the 2 elements we have already used in the previous 2 compartments. That's why for the last one, it will be 3 minus 2, 3 minus 1. This one will be 3. So 3 into 3 minus 1 into 3 minus 2. So this is very, very important thing which you must remember. So suppose we have n objects. Suppose we have n objects. So here we are just showing you an example, basic thing, 3 objects taken 2 at a time and then 3 at a time. So here we have taken 2 at a time and here we have taken 3 at a time. Now suppose we have 3 objects. Now the general thing. Suppose I have 3 objects and if I take r at a time, if I take r objects at a time, then that will be denoted as npr. That will be denoted as npr, right? Now here 3p2 was equal to what? 3 into 3 minus 1. 3p3 is equal to what? 3 into 3 minus 1 into 3 minus 2. So here npr will be equal to n into n minus 1 into n minus 2 dot 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 n minus r. So this is what permutation of n objects taken r at a time. So the definition of this thing is what? Permutation of n objects taken r at a time. So one thing, it won't be n minus r, won't be the last term. The last term will be n minus r plus 1. It will be n minus r plus 1. Okay, so this is what we have. Because you see, when you're writing 3p2, the last term is what? It's 1, right? It's in here, it's 1. It's less than 2. That is 2 minus 1 we have. So here basically what we are getting is, it will be n minus r plus 1. N minus r minus 1. N minus r minus 1. So this is what we will be getting. So this is equivalent to what? N minus r plus 1. Clear? You see, you're getting what? 3 minus 2 minus 1, right? That is 1. You're getting here 3p3. So the last term you're getting as what? 3 minus 1, that is 2. So n minus r minus 1, you will be getting n minus r plus 1. Okay, so that's what permutation is all about. Now what is factorial? What do you mean by factorial notation? So I will write here factorial. So what is factorial? Suppose I have 5 factorial. Now 5 factorial is equal to 5 into 4 into 3 into 2 into 1. It is the product of all natural numbers before 5 and 5. So if I have n factorial, that will be equal to n into n minus 1 into n minus 2 into dot 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 1. So product of all natural numbers less than and equal to n. That's what factorial means. So 1 factorial is equal to 1, and the most important thing, 0 factorial is not 0. 0 factorial is 1. This is a very very important thing which you must remember, or else you will get this thing wrong. So factorial, you have learned, it is nothing but it is product of all the natural numbers less than and equal to n. So that's what factorial is all about. Yeah. So let's do some problem of exercise 7.2. So exercise 7.2, what we have in here is, so evaluate 8 factorial. So my question number 1 is, we have to evaluate 8 factorial. So 8 factorial will be equal to what? 8 factorial will be 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Then you multiply them and you find the value. That gives you that value of 8 factorial. Question number 2, it's very very easy. Just find out the value. Question number 2. Question number 3. All these are easy. Let me do question number 4. Let me do question number 4. So question number 4 is what? 1 by 6 factorial plus 1 by 7 factorial plus x by 8 factorial, and we have to find what? Sorry, it is equal to, not plus. This one is equal to. So 1 by 6 factorial plus 1 by 7 factorial is equal to x by 8 factorial, and we have to find the value of x. So let us start with this question. So here what I will do is, I will try to write 6 factorial is how much? 6 factorial is equal to, actually I'm going to write like this, and this becomes 7 factorial. I can write it as 7 into 6 factorial, because 7 factorial is what? 7 into 6 factorial, and that is equal to x into x divided by 8 factorial. So now if I take 1 by 6 factorial common, so I get 1 by 1 plus 7, and that too I get x by 8 factorial. If I take 1 by 6 factorial, I get 1 plus 1 by 7. Now let's do the LCM. So if I do LCM, I get 8 by 7 is equal to x by 8 factorial. Now let's take this 8 factorial this side. So what do you get? 8 factorial by 6 factorial into 8 by 7 is equal to x. So now let's cut. Now 8 factorial is equal to what? It is 8 into 7 into 6 factorial. 6 into 5 into 4 into 3 into 2. So if I cut these two, I get 8 into 7, and this 7 goes. So we get what? 64. So therefore x is equal to 64. So that's how we find the value of this equation. Now let's do question number 5. Let's do question number 5. So question number 5 is what? It is evaluate n factorial by n minus r factorial. So we have to find this n factorial divided by n minus factorial when n is equal to 6. For the first one we have n is equal to 6 and r is equal to 2. So we have to find the value of this thing. So if I put n is equal to 6 in there, we get 6 factorial divided by 6 minus 2 factorial. So we have 6 factorial divided by 4 factorial, and we know 6 factorial is what? 6 into 5 into 4 factorial divided by 4 factorial. So this 2 goes away. So we have 30. So we got the value of 6 factorial divided by 6 minus 2 factorial. So like this way, please complete this exercise.